This lesson will cover how to set up functions. Most of us know that function notation is f of x, and that means that the name of your function is f and the input variable is x. And what that's doing is saying I want to express this function f in terms of just the variable x. Since we don't know what kind of job you're going to go and do, whether it's engineering or economics or whatever, we'll have to stick with examples which you're familiar with, which is mostly geometry and algebra. So examples that we might see would be something like express the area in terms of the width. In function notation, that's area is going to be expressed with width as an input. So on the right side of my function should only be the variable w. And we can do the same thing for perimeter as a function of side, cost as a function of units produced, and profit as a function of number of units sold. In each of these cases, we're expressing the thing on the left using the variable inside the parentheses, and all of your functions should have just that variable on the right side. To help us fight through the geometry questions and algebra questions, we'll try and keep these 4 steps in mind. Draw a picture and make sure you know what the question is, in other words, what function are you aiming for. Be sure to define your variables, label your picture, and then use an equation to help you form your function. Alright, example 1. It says the perimeter of a rectangle is 50 feet. Express its area as a function of the length of a side. So the 2 things I need to do are find a function for the area, and I need to have a picture of a rectangle. So here is my picture of a rectangle, and it's labeled with length and width. The question I'm answering is, how am I going to express the area as a function of, and I picked the length. You could pick width, but it really doesn't matter. I want the area written as a function of length only. I wasn't given an equation, but I do know that the perimeter was 50, so if I look at my diagram and say, well, perimeter is the distance all the way around, I think the equation that I could write would be 2 length plus 2w equals 50. I know that the formula for area of a rectangle is length times width, so my equation and my function are almost complete. The only problem is this w right here. If I'm going to write area as a function of just the length, this L variable here is okay, the w needs to go. I'll take my equation, solve it for w, and substitute it in so that only L's will appear on the right side of my function. I think we know the steps for solving for w. Subtract 2L from both sides, divide by 2. Since both of these are even, they can both be reduced. I know that w is 25 minus L, and my function for the area of a rectangle in terms of length only, 25 minus L times L. Final answer after I distribute the L. The area as a function of length, 25L minus L squared. So that's a pretty good template for what we need to do for everything. Write down the function that you're looking for. Write down the formula. The formula has too many variables. I'm going to need some sort of an equation. Solve for the variable that I don't want. Substitute it in. And now I have a function in just one variable only. So the second example involves another rectangle. This time, however, it's inscribed inside of a circle with radius 5. So again, I think I need a diagram. I'm going to draw a circle. To show that my radius is 5, I need to find the center. But I also need to put a rectangle inside the circle, and people get inscribed and circumscribed confused. If it says in a circle, the rectangle is inside the circle, I think I need that rectangle. Now the trick is to use the radius of 5. I'm going to set up my question. Perimeter as a function of length. I've got length up here. I need to write the perimeter all the way around. But the only information I was given was that the circle has a radius of 5. I could draw a radius here, but that really doesn't do me much good. That's a radius for the circle, but it doesn't really involve the rectangle at all. The radius I think that would be better connects both figures, and so now I have this length of 5, which is the radius of the circle, also using the rectangle. So while I have a formula for the perimeter of the rectangle, 2 length plus 2w, I need to somehow get it in terms of just L. I need the w to disappear. I need an equation. If I look at my diagram and say, well, how do I connect an equation with L, W, and the given information of 5, I think drawing one more line right here helps out. now that I have this length of 10 diameter, I could go ahead and make a triangle. And since rectangles have right angles, I think that the blue triangle is a right triangle, and the equation that I could use is the Pythagorean theorem. L squared plus W squared equals 10 squared. And now I have the function that I'm aiming for. The W needs to disappear. I have an equation. I can solve it for W. Subtract L squareds from both sides, square root. I only need the positive version because of what W stands for width, and it needs to be a positive quantity. No such thing as a negative width. If I take and replace this into my function instead of the W, I get a new function that only is written in terms of L's, and that's my answer. I've got the perimeter in terms of length of the rectangle being 2L plus this quantity here. So I think that problem's done, and we're ready to move on to the third example. The third example is going to be using algebra. This time I've got a point on some sort of quadratic function, and the distance from a point on that function to the fixed point 6, 0 needs to be written as a function of just one variable. So I set up my answer. I need to express the distance as a function of x. In order to see what's going on, I think I need a diagram. And I think I need to plot this parabola. Now you can pick and choose points, but I think we could almost complete the square in our head to find out where the vertex is. I know it's going to open upward because the coefficient of x squared is 1. If I complete the square in my head, I need half of this term, which is -2, and to square that, which is 4. And then to offset the fact that I've just added 4 here, I need to subtract 4. So the 9 is going to become a 5, and the perfect trinomial square factors down into x minus 2 quantity squared. So if I draw a parabola with vertex at 2, 5 facing upward, I'll get something like that. I also need the point 6, 0. And then I need some point on the parabola. So I don't know where to draw it, and I'm going to label it with just a plain old xy. So I've taken the information that they've given me and I've created the diagram. I know my question is find the distance in terms of one variable only, and I just picked x at random. I have a picture over here, and the distance that I need to find is that length there. But since p can move around, it says it can be anywhere on the parabola, the distance is going to keep changing. So my answer is going to have a variable in it, and the only variable that I want is x. So how do we tackle that? Well, I think if I'm going to go from a point to a point, I'm going to need the distance formula. So I start with the distance formula. I need to take and subtract the difference in the x coordinates, add the difference in the square of the y coordinates, and then square root that quantity. I've got way too many variables here. I've got 4 different ones. First thing I can do is replace one of the xy pairs with the point that I have, 6, 0. So changing x1 and y1 into 6 and 0 gives me this. I'm at least down to 2 variables now. I have an x and a y. If I want to write the distance as just the function of x, y can be changed into x squared minus 4x plus 9. So I replace that y with that quantity there, and I think I'm done. The distance between those 2 points is a function that only has x's over here. You could simplify that a little bit, but I think that we've got enough information to satisfy the question that was asked. Write the distance in terms of just one variable x. X minus 6 quantity squared plus x squared minus 4x plus 9 quantity squared. So that's the third example. The fourth example is another geometry algebra type question. A right triangle has one vertex on y equals 25 minus x squared. Again, I think I'm going to need a diagram. If I need 25 minus x squared, I believe that's a parabola opening downward because the x coefficient is negative with a vertex at 0, 25. So I'm going to draw that in. There's my parabola. The triangle has one vertex at the origin, which is 0, 0, and one vertex at x0. And what I think that means is that the point is going to be moving along the x-axis anywhere. Okay? The third vertex is actually on the parabola function here. So as I move the point D, this point E should move as well, and the connecting these 3 points creates a triangle. So again, as I move D around, the triangle is going to keep moving. And so the question says, express the area of the triangle as the function of one variable. So I set up my answer. I need area as a function of one variable, and again, I've picked x. And the other piece of information that I was given is that the triangle has one vertex on y equals 25x squared. I think that's my equation. So to start with the area part, the formula for area of a triangle is 1/2 base times height. So I write that down. I look at my diagram and say, well, I think the base down here, starting at the origin and going to the point x0, is going to have a length of x. That's good because I want my function in terms of x. The height, on the other hand, is the y coordinate for this point E. So the first step in solving my area function is 1/2 x times y. But the good news is I know that since E is on the parabola, my y value is always going to be 25 minus x squared. No matter where I put x, the y value for E is always 25 minus x squared. And so changing this y into 25 minus x squared produces a function, again, that's just in one variable. So that's it. So the first 4 examples have all been trying to demonstrate that functions start by building a formula that might have more than one variable and slowly building it to the point where only one variable remains. And in most cases, you need an equation to plug into the function so that you can write your function as just one variable. Example 5 goes back to geometry and says a piece of wire x inches long is bent into a circle, and you're supposed to express the area in terms of x. So my diagram is going to look like a circle, which is right here. And if I take and bend a piece of wire into the shape of a circle, I know that I've just created the circumference. So for my answer, I'm going to start out with the area as a function of x, where the circumference is the same thing as x, and that means that my piece of wire x inches long is the circumference of the circle, and now I've got to take and use that x to find the area. Well, I think in order to find the area of a circle, I need a different formula, which is pi r squared. I know that the circumference of a circle is 2 pi r, so on my function, the r needs to disappear, and I need to have the x appear. Well, how am I going to convert an r into an x? If I take and realize that the circumference written 2 different ways, x equals 2 pi r, I can solve this for r and plug it in over here. So the key is realizing that circumference, the thing that I was given, can be written 2 different ways, once in the given information and once using the geometry formula. Solving that for r, I get r equals x over 2 pi. Putting that into the function produces area is now pi times x over 2 pi squared, and doing a little bit of simplifying produces x squared over 4 pi. 2 squared is 4. Pi in the denominator squared is pi squared, but 1 in the numerator cancels with 1 in the denominator, and x squared is x squared. So there's my answer. I now have written area for the circle in terms of the circumference, which was a piece of wire, which was x. So that problem is done. Example 6 is more geometry, and this time it's a right circular cylinder. I'm given a volume of 10 cubic centimeters, and I need to find the surface area as a function of the radius of the base. So my diagram needs to be a right circular cylinder right here. I need to add a couple labels, and the labels I need are for volume of 10. Well, that's just more of an equation, volume equals 10. And I need to find the surface area as a function of the radius of the base. So I'm going to draw in a radius. And I think I'm also on my diagram going to need the height, because while I can find surface area using the area of a circle, and area of a rectangle, I'll come back to that in a minute, in order to find volume, I think I also need the height labeled. So I have my diagram, right circular cylinder, radius, and height labeled. And now I'm going to start working with the geometry formulas. What is the surface area of a right circular cylinder? Well, if you had to paint this, you would be painting three different surfaces. The bottom, which is a circle, and the top, which is a circle. So far the surface area is two circles. And then the label part, and I call it a label because this looks like a soup can, and if I were to cut vertically and unfold the label of the soup can, I would get a rectangle. So the formula for the surface area of a right circular cylinder is 2 pi r squared. I've got two circles, a top and a bottom, and then I need the area of a rectangle. Now a rectangle is length times width, but in this diagram here, the height is one of the dimensions, and the other dimension is the circumference of a top or bottom circle. And that's because when I make my cut on my label, straight up and down, and when I lay it flat, laying it flat produces the circumference as a dimension of the rectangle. So 2 pi r is the circumference of a circle times the height is really just nothing more than the width times the length for a rectangle. Once I've got that written down, I know that the volume formula for a right circular cylinder is pi r squared h. You take the area of the base, which is a circle, pi r squared, and multiply it by the height. So volume is area of a base times the height. Area of a circle is pi r squared, height is just height. So now that I've fought my way through two geometry formulas, surface area for a right circular cylinder and volume for a right circular cylinder, again, just like the last example, I've got volume written two different ways. I can set 10 equal to my volume formula, and I look at what I'm aiming for. I need the surface area in terms of the radius only. 2 is okay, pi is okay, r is okay, 2 is okay, pi is okay, r is okay, h needs to go. So I think I'm going to take this formula over here and solve it for h. Divide both sides by pi r squared. I get 10 over pi r squared. Take and substitute that h into the formula on the left. And now I have the surface area written with the only variable being r. I've got 2 pi r squared plus 2 pi r times h written a different way. A little bit of basic simplifying. Pi cancels with pi. R over r squared leaves an r in the denominator, and 2 times 10 is 20. So the formula for the surface area of a right circular cylinder, written in terms of only the radius, is 2 pi r squared plus 20 over r. The seventh example is one of the rare ones that's not going to need a diagram. At this point, you should be able to maybe attempt some of these on your own, so if you want, go ahead and pause the movie and see if you can answer this without my help. The question is, two numbers summed to be 100. Express the product p in terms of a single number. So if you've got an answer, you can check it now. I'm aiming for the product in terms of a single number. I'm going to call my two numbers x and y, and so the function that I've set up is product in terms of x only. And then the equation I have is that if I'm told that the two numbers sum to be 100, I'm going to say that the first number plus the second number equals 100. Well, if I need x only, I'm going to start with product and say product is x times y. X only means that y needs to disappear. I think I'm going to take that equation, solve it for y. Y is 100 minus x. Substitute it in over there, and I have the product as a quadratic in just one variable. The last example comes from economics. Revenue, how much money you bring in, is defined as the price you charge times the number that you sell. So in terms of variables, revenue equals price times x. Price is often a function of the number of units produced. So I've got price as a different function. Price is some sort of linear function, m times x plus b. Your price could be based on some cost per unit and an initial or a setup bunch of costs. Suppose the price demand curve is negative 1/2 x plus 16. So my price function is given to me. I know that the price is going to start at 60 bucks, but for every unit that I sell or buy, the price is going to be decreased by 50 cents. And it says, express the revenue as a function of x. So I'm going to come over here, set up, my answer. So I'm aiming for revenue. And because all of this is algebra, I think I actually can have a diagram for this. And I'm going to start with a price function that's linear. If my price function is linear, my y-intercept is 60 and my slope is negative 1/2. I've got a grid here that starts with a y-intercept of 60. Slope is negative, so I know it's going to be going down. And since it goes down by 1/2 per unit, I think it's going to take me about 120 units to get all the way down to the bottom. So if I put my price function on there, I've got a nice straight line decreasing. I need a revenue function in terms of x. So if x is the number of units produced, I need to create a revenue function. Well, revenue is defined up here as price times x. So the first thing I'm going to do is write down my revenue function, p times x. P is no good, but I was told that the price function is negative 1/2 x plus 60. So what I'm really doing here is taking one function and plugging it into another function. We did composition of functions earlier. It's the same thing now. Replacing the p with negative 1/2 x plus 60 gives me this. And then my revenue function is complete. It's written in terms of only one variable. I can look at that on the same exact graph as the price function. Because revenue is going to be much more than just the price, I'm going to need to scale this down. And I can see that my price function is quadratic. Sorry, take that back. My revenue function is quadratic. So I'm done.